Okay, first thing we have is a definition. You'll hear me talk about mutually exclusive events a lot. And mutually exclusive, another word for that is disjoint. So if I say two things are mutually exclusive, it means they cannot both happen. So I would say the probability that you are sitting in my classroom right now and the probability that you are in the gym taking the ASVAB. Those are mutually exclusive.
If you have not dismissed your juniors, please do so at this time. Juniors to the gym for the ASVAB.
It is impossible for you to be both places at once. Now, if I said the probability that you are sitting in my classroom right now and eating breakfast, are those mutually exclusive? Can you be in my classroom and be eating breakfast at the same time? Yes. So those are not mutually exclusive. So mutually exclusive, they have no common outcomes. They cannot both happen at once. Another word for that is disjoint. So this is our first probability formula. On your formula sheet, under chapter 5, you have the top of the second column, addition rule for disjoint events. If they're disjoint, which means mutually exclusive, then the probability of one or the other happening is found just by adding those probabilities together. So it's on your formula sheet, you always have it, you just have to know how to use it. So let's look at a problem. Okay, so here's a probability model that shows the distribution of the number of rooms and housing units in the United States. Verify it's a probability model. What do you have to look for if it's a probability model from yesterday?
If those are equal to 0.
Every single probability is between 0 and 1, which they are. And we have to make sure it adds to 1. So add those up real quick. Does it add to 1? So anytime I'm asking you if something's a probability model, those are the two things you're checking. What's the probability that a randomly selected housing unit has 2 or 3 rooms? So the probability of 2 or 3. Is that mutually exclusive or disjoint? Can a housing unit have both 2 and 3 rooms total? No. So all that means is we can use our addition rule. You just have to add the individual probabilities. So the probability of 2 rooms is 0.032 plus probability of 3 rooms, 0.093, and we get 0.125. C, what's the probability a randomly selected housing unit has 1 or 2 or 3 rooms? What do you think we have to do? Yep, it's probability of 1 plus probability of 2 plus probability of 3, and we get 0.135. Now this option of just adding our probabilities only works if it's mutually exclusive, if the two can't happen at the same time. We have to talk about what happens if we can have something that is not mutually exclusive. So for instance, if I wanted the probability that a student in this high school is in my class or Mrs. Dyer's class, or not at this moment, but just overall in their day. Can you have both my class and Mrs. Dyer's class in the same day? Yes. So if I just added our individual probabilities, I have double counted those students that are taking both college algebra and geometry. They got counted with my group and they got counted with her group. So what would I need to do with those kids? Yeah, and we would have to subtract off those people that I counted twice, right? So that is our general addition rule. So if it's not mutually exclusive, you add your probabilities, but you have to subtract off those outcomes that got double counted. So you're subtracting off the overlap. So let's look at a problem. Let's say we're going to roll 2 dice and look at our outcomes. Okay, so for each dice it's just regular 6-sided dice. I put a picture up here just to kind of help us illustrate what that looks like. So this is my sample space, all my possible outcomes. We have, both could be a 1. The first could be a 1 and the second could be a 2, or the first could be a 2 and the second could be a 1. So I listed all those out here. Let's suppose E is a probability the first die is a 2. F is the sum of the dice is less than or equal to 5. I want the probability of E or F. So from what we wrote down, that's the probability of E plus the probability of F minus the probability of both. The probability of E. E says the first one is a 2. So the first one being a 2 are those right there. We have a 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. So we have 6 options where the first one is a 2. Out of how many total combinations did we have here? 36. The probability of F. So F says the sum is less than or equal to 5. So 1 and 1, 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, but we can't do 1 plus 5, right? We could do 1 and 2, 1 and 3, 1 and 4. We could do 2 and 2, 3 and 2, and 2 and 3. So those are all the ones that are less than or equal to 5 when you add them up. How many did we count there? 10 out of my 36 total. Minus, how many of those got double counted? 3. These 3 right here, I counted twice, so I need to subtract those off. So that gives me 16 minus 3, so 13 out of 36. 4 as a decimal. 0.3611. Is that all right with everybody? I tend to do a lot of card examples when I'm doing probability. Are you familiar with a deck of cards? How many cards are in a deck? 52 if you don't count jokers. How many suits are there? 4. You don't play cards.
I mean, I'm starting to, but
How many cards are in a suit?
13.
13. Because there's 52, and if you divide that by the 4 suits, you get 13 cards in a suit. Okay? Let's say so I want to draw a card out of my deck of cards. I want the probability of drawing a king or drawing a diamond. As we get into these probabilities, a lot of times you will see me kind of writing out, I want the probability of king or diamond. And I use my formulas a lot because when we start doing more things, keeping your formula straight is really huge. So I need the probability of king plus probability of diamond minus the probability of both. Okay, so the probability of king. How many kings are in the deck? Out of how many total cards? Plus probability of diamond. How many diamonds are in the deck? Out of minus. How many cards are both a king and a diamond? 1, just the king of diamonds. So that got counted twice. It got added into the kings and with the diamonds, so we have to subtract it off. So that gives me 16 out of 52. Or if you gave me a decimal, 1.3077. Questions so far? The nice thing is, when you're using your OR, we have those 2 different OR formulas. If you always use this one, if your events are mutually exclusive, what would be the probability of both happening? 0. If I had said I wanted the probability of a diamond or a heart. Okay, if I set it up like this, probability of a diamond, there's 13. Probability of a heart, there's 13. Minus, how many cards are both a heart and a diamond? 0. So if you don't remember, you can always use this formula. You don't necessarily have to think, oh, I need the separate mutually exclusive formula. You'll get there from here. When you go to subtract off the overlap, you'll realize, oh, there isn't any, that's just a 0. Okay, so here is a table. I have males and females in millions, and I have marital status over here. We need to add up some things. If we're going to find probabilities, we need totals. So I need my total number of males. Total for the females. And my grand total for the table, if I added those together, is 251.3. Okay, so part A. The probability that a resident is male. How many males do we have? Out of how many total? places unless I specify otherwise. The probability of being widowed. So what do we have to do? Probability of being widowed, so you have to add those together. So that's 14.3 out of my total.
0.569. 0.569.
Thank you. Let's see, what's the probability of widowed or divorced? So that's the probability of being widowed plus the probability of being divorced. Can we have overlap here? No, so we don't really have to subtract off, it'll just be 0. So the probability of being widowed, you can take the decimal we already found or this fraction. Probability of being divorced, if you add your divorce that's 0.15797, so 0.1580. Last one, the probability of male or widowed. Could this one have overlap? Yes. So we have to do the probability of a male plus the probability of widowed minus the probability of both. So, probability of being male, you can use the fraction, you can use the decimal since we've already calculated it either way. I'll just do my decimal. Plus probability of being widowed, we found that in part B. Minus the probability of being both a male and widowed would be 3.1 over my 122.5. Okay, what'd you guys get? To denote that, you'll see sometimes an E with a little C up the top. You might also see just a bar over the top. That's just another way of writing a complement. So it's basically the exact opposite. Everything in my sample space that's not that value. We know the total probabilities add up to 1, so if I know the probability of being 5 or under is 0.3, then the probability of not being 5 or under will be 1 minus that 0.3, because together they make up the entire group. Just to wrap it up today. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability that a household does not own a dog? So what this is saying, the probability that you have a dog is 0.316. So the probability of no dog would be what?
0.62.
You just have to do 1 minus that. And you get your 0.684. If you wanted to give that as a percent, what would you say?
60.
Because these are complements. There's no other option. Or you have a dog or you don't have a dog. Okay. Okay, it's not possible to own half of a dog. You either have one or you don't. All right, I would like to do another example. The situations I've given you, I kind of put it in terms of a problem, you know, the probability being male or widowed. But sometimes on your homework, it might just have the probability of A equals this, probability B equals this, and you're really just using your formulas. So sometimes these are harder for people because there's no actual like context for the problem. But I'm telling you the probability of A is 0.4. Probability of B is 0.5. Probability of A and B is 0.1. So find the probability of A or B. When I do these, what I recommend is writing out the formula. So the probability of A or B. If you're looking on your formula sheet, that's like your probability of, what did it have, E or F on here. It's the probability of the first one plus the probability of the second one minus the probability of both. So if you write out your formula, we can just solve. I don't know the probability of A or B. What's the probability of A? 0.4. Plus, what's the probability of B? Minus, what's the probability of A and B? And you get 0.8. Second one, I gave you probability of A, probability of B, probability of A or B. And I'm asking for the and this time. So, same starting point. You write your formula. Probability of A or B. Probability of A plus probability of B minus probability of A and B. What's the probability of A or B? 0.7. Probability of A, probability of B. I don't know the probability of A and B. Now, is that difficult to solve for? No, it's just solving a linear equation. So if you subtract over your 0.9, you get a negative 0.2 equals a probability of A and B. So the probability of A and B is positive 0.2. So you might have to manipulate these formulas a little bit and solve for your unknown, but it's just a linear equation. All right, last one. So I'm still talking about, I've got a probability of A or B in here, so I'm still using the same formula. We're plugging in what we know. The probability of A or B, probability of A, probability of B, we don't know, minus probability of A and B, 0.1. Add like terms, 0.4 and negative 0.1, 0.3. Subtract over your 0.3. Probability is 0.6. Any questions for me? So, on tonight's homework questions, I want you to follow the same thing I told you yesterday. So, you don't have to interpret the probabilities unless, like, that is the only thing the question asks for. So if part B says interpret, then I want you to write the sentence. But if it ever says find and interpret, you